What is this garbage? How did I think this was a good idea? It places a score on a random entity several times. No. This can be improved. Welcome back to my map, Space Aces. Last video we worked on updating to Minecraft 1.21, and we got everything working. But through this process I found something hideous. Something terrible. Something so bad I had to change it. What was it? That's right, my coding skills from several years ago. So that's what we're tackling today. And while we're doing this, please excuse my sick voice. Looking at our goal log, here are some of my major ideas. Of course, we'll be doing minor improvements too. For raycasting, we're going to be looking at reducing the step size to 1/8 of a block from 1/16. We also may do some research on running some checks per block instead of every single step on the raycast. But we'll also look at doing some improvements to the randomization, as well as utilizing macros for certain expensive functions that can be optimized easily. I also got a list of more specific areas that we will be looking at too. While you're trying to optimize, it's pretty easy to make changes that you think are going to be good, but for one reason or another, they end up being bad. So what we're going to need is to gather some baselines. We can use Minecraft's built-in F3+L keybind to start a 10-second tick rate capture. Now, obviously this isn't going to be an exact science, but we can just get a ballpark figure. Plus, I'm gathering 3 data points for every change that I'm making. During my livestream a while back, we set up a rig to gather some data points specifically for these things. Well, first of all, the baseline, which is just the normal tick capture with nothing else going on. And then we'll be capturing some data points for some classes that are shooting constantly. And the reason they're shooting constantly is going to help see us exactly what benefits specifically the raycasting and the firing parts of each class. So first we're going to be capturing Soldier, which is kind of a general idea for all of the classes. He's kind of like the baseline. We've got Gunner, which is a simpler version of that. Mechanic, which helps us to see what shotgun spread looks like. Sniper for extra long distances. Bomber for explosion checks, how projectiles work too, and then Shocksmith to see if there's any difference between different projectiles. And after capturing these, looks like for the baseline, we're running at around 8.65 MSPT, and here are what the classes are currently running at. So getting started with making our changes. I wanted to make an easy win change with the way the armor was being checked, converting it from a constant NBT check to just a simple predicate. And NBT checks are very frowned upon in terms of performance. Then I wanted to convert the way entities are ticked in the game. Currently they are a bunch of different @E checks, which each automatically specify which entity they're trying to tick, but I'm going to convert that to a singular @E check, and then within that function it will narrow it down to which entity should be doing what. But after doing that, it actually made the MSPT go up, which is bad, instead of down. I thought this would work, so what's going on? Oh, there were thousands of entities from a slightly broken function from the update. They were just sitting there doing nothing, and because there's so many of them, it slowed down the main @E check. Once we killed all of them, we took more measurements and noticed a significant improvement. I also did a handful of other optimizations that aren't too exciting to the main tick, bringing the main tick to just under 6 MSPT. Now it's time to work on improving the raycasting. And I'm going to focus on first making Soldier generally better, then apply those changes to the more specific cases brought up by the other classes. In terms of ways to improve, the first and most easy thing to change is going from 1/16 of a block step size to 1/8. And with almost no effort, we went from Soldier's 36.3 MSBT to 21.67. And that kind of makes sense because we're really ultimately halving the amount of functions that need to be ran to do the same thing. I also wanted to try kind of doing a fake version of voxel traversal, running sub-block specific checks only on entering a new block. The reason we care about what type of block the projectile is in is to see if it should be killed or if it should keep going on. So for example, if the projectile is going through a slab, if it hits the block part of the slab, well, we want to kill the projectile. And conversely, if it goes through the air part of the slab, then we of course keep it going. So what I'm kind of thinking of doing is only running the check for which type of block it's in when the projectile enters that block, instead of every single tick looking through the list and seeing, hey, which block am I looking at? But after doing kind of a test version of all of this, it just made things worse, and measurably worse. It's not like give or take a little bit, it was a good chunk, as we can see here. So for now we will be scrapping that idea, and if you have a better idea, let me know. Moving on from that then, I noticed that the spread function was just a little unusual. Instead of adding the spread just once, I had a recursive function that I could add any value to that would add just a little bit more spread each time. So if you have a high spread, you would be running that function a whole lot more than either 0 or 1 low spread. The worst part about that function is it uses the same randomization technique that I fixed in the YouTube short I made on optimizing these things for space aces. So it used @e selectors, which is always bad. So instead what I wanted to do is use a macro, which I could just input a value in, and then automatically it would run just once and spread the bullet by teleporting it to a certain direction. And after doing that, it seems like it has just a little bit more overhead, but it's less recursive. And so that means that things with a wider spread benefit a lot more from this change, as we can see in the mechanic class. The only side effect is that the spray pattern is slightly different, but let me know how you feel about it. Next, reducing the frequency as well as the size for when the hitboxes are checked can benefit us too. And we can see doing this, as well as some of those other changes, brought Soldier down to 21.26 MSBT. Finally, after doing some other minor optimizations, we're looking around 22 MSBT for Soldier. For Gunner, we went from 35 to 20, Sniper went from 123 to 72, Mechanic 67 to 35, Bomber 55 to 33, and Shocksmith went from 64 to 34. All of these are pretty big changes. Here's my new favorite segment, bug squashing. I changed the raycast anchoring, which was manual before, to being anchored strictly to the eyes, but that caused a problem with bomb anchoring. I replaced the armor stands with item displays for the projectiles to help with performance, but I forgot to set the interpolation distance, so it kind of had a choppy effect. Rockets just started not dealing damage, that's fixed. And Brawler was a little overpowered because he was always headshotting. Why is he even able to headshot in the first place? Anyways, that's fixed. Now Space Aces is running, well, at least a little bit better. I'm sure you have a lot more insight on some of my problems than I do even. But I'd like to thank you for watching and for being patient with my upload schedule, as well as me being sick throughout this video. I look forward to seeing you next time.